All right, let's peel back the curtain on reality itself. Today, we're digging into the invisible forces, the unseen rules that dictate how literally everything moves in our universe, from a simple rolling ball all the way to the planets in the sky. So let's get right into it. You know this feeling, right? The car takes a sharp left and your whole body gets slammed against the door on the right. It feels like some mysterious force is just shoving you. But what if I told you nothing is pushing you at all? What you're actually feeling is your body trying its best to obey a fundamental law of the universe. And that brings us to our very first unseen rule. Now, officially, it's called Newton's first law of motion. But, I like to call it the law of laziness. Why? Because it basically says that all objects are kind of lazy. They just want to keep doing whatever they're already doing. If an object is sitting still, it wants to stay still. If it's moving, it wants to keep moving in a perfectly straight line at the same speed. This built-in laziness has a scientific name, of course, inertia. It's just a natural resistance every single object has to any change in its motion. And what's the secret to how much inertia something has? Well, it all comes down to its mass. The more massive something is, the more it fights you when you try to push it around.
Think about the classic tablecloth trick. It's the perfect example of inertia. See, the dishes have what we call inertia of rest. They really want to stay put. So if you yank that tablecloth out from under them fast enough, you're not actually applying a force for long enough to overcome their stubborn, lazy tendency to just sit there.
And here's the other side of that coin, inertia of motion. We've all done this, right? You shake a ketchup bottle down really hard. The ketchup inside is moving right along with the bottle. But when you abruptly stop the bottle, the ketchup inside wants to keep going. Its own inertia carries it right out of the bottle and, hopefully, onto your food. Okay, so if everything has this built-in laziness, this resistance to change, how does anything ever speed up or slow down or, turn? Well, to overcome inertia, you need a push or a pull. You need a force. And that leads us to our next big idea, the connection between force, mass, and this thing called momentum.
So what exactly is momentum? The easiest way to think about it is as mass in motion. It's the sheer quantity of movement an object has. And it's not just about how fast something is going. It's a combo deal of an object's mass and its velocity, which is really just a fancy word for speed in a certain direction. So the more mass or the more velocity an object has, the more momentum it's packing.
For example, think about this. A tiny little bullet has a huge amount of momentum. Why? Because its velocity is just off the charts high. But at the same time, a big, heavy bowling ball rolling along pretty slowly can have a very similar amount of momentum, just because its mass is so large. The impact from either one can be incredibly powerful.
And this is where the physics gets incredibly real and serious. The reason high-speed car accidents are so devastating is all because of momentum. A car moving at high speed has a massive amount of it. And here's the crucial part. That momentum has to go somewhere. It doesn't just disappear, it gets transferred. And in a crash, it's that violent, instantaneous transfer of momentum that causes all the damage.
This brings us to the third, and maybe the most mind-blowing of these unseen rules. It's the one that tells us that in this universe, nothing ever acts alone. Every single push, every single pull is part of a cosmic dance. For every action, there is always an equal and opposite reaction.
And there it is, straight from Isaac Newton himself. It's like a universal two-way street. If you push on a wall, that wall is, in that very same instant, pushing back on you with the exact same amount of force. No exceptions. It's always a pair.
Let's break it down with a swimmer. You might think a swimmer pulls themselves through the water, but that's not what's happening. The swimmer's action is pushing the water backward with their hands. So what's the reaction? The water pushes the swimmer forward with equal force. That's what moves them.
And once you see it, you see this principle absolutely everywhere. A bird pushes air down. The air pushes the bird up. A helicopter's giant blades push a column of air down. The air pushes the helicopter up. A rocket throws hot gas down at incredible speeds. That gas pushes the rocket up into space. It's the exact same rule every single time.
Okay, so for the grand finale, let's take everything we've learned about inertia, forces, action, and reaction and scale it up. Let's go from things on Earth to the entire cosmos. Because it turns out, the very same force that makes an apple fall from a tree is the one that orchestrates the magnificent dance of the planets. And that force is gravitation. It's this universal attraction between any two objects that have mass. And here's the part that'll bake your noodle. Its range is infinite. That means every single atom in your body is, technically,
pulling on the most distant star in the universe, and that star is pulling right back on you.
So the famous story goes that Newton's big aha moment started with something super simple. He just saw an apple fall from a tree. It went from being still to speeding up as it moved to the ground. He knew some kind of force had to be acting on it. And this is the leap of absolute genius. Newton looked up at the moon and realized that the moon is also falling. Its inertia wants it to fly off in a straight line deep into space. But at the same time, the Earth's gravity is constantly yanking it back inward. An orbit is just this perfect, beautiful balance between the moon's tendency to fly away and the Earth's constant pull. It's basically falling and missing, forever. When you think about it, this one unseen rule gives our entire world its structure. Gravity is what holds us on the ground. It's what keeps the moon circling us, and it's what keeps the Earth circling the sun. It even reaches out and pulls on our oceans to create the tides. It's truly everywhere. So once you really get these rules, inertia, momentum, action-reaction, gravity, you honestly can't help but see the world in a whole new way. Every little movement, every interaction you see becomes this amazing demonstration of these elegant, universal laws.
So I'll just leave you with this question to think about. If every action really has an equal and opposite reaction, what unseen forces are shaping your world right now? I mean, the chair you're sitting on is pushing up on you with a force exactly equal to gravity pulling you down. What other invisible pushes and pulls are defining your reality at this very moment?